Good afternoon, everybody. Thanks for being here. We appreciate it. We are going to good, Sam has joined us. I'm excited to have two innovators also join me on stage. Dale Moore from Davidson, as well as Aleksandar Davidov from Ruter. And we are excited to have a panel today talking about public sector innovations and ways in which to use quantum to help serve the public sector. So Sam, who's joining us virtually, he is with the U.S. Army Engineer Research and Development Center based in Biloxi, Mississippi. His team works on applications for the U.S. Army Corps of Engineers, and he has a PhD in applied mathematics and computational analysis. He's worked on several applications, and we're excited to hear more. You heard from Dale yesterday for some of the work that Davidson is doing, and we're going to delve into a bit more with him, and then obviously with Aleksandar Davidov on the transportation cycle and transportation network. So with that, I'm Allison Schwartz, the VP of Global Government Relations for D-Wave, and I'm excited to start off with Sam. So Sam, thanks for joining us virtually. I know that you and your team has been working on wildfire management issues, something that's important here in the US as well as around the globe. And so I'm wondering if you can take just a moment to kind of share what you all have been working on in that space.
Sure. So thank you, Allison, and thank you to the D-Wave team for inviting me. Glad to be here, and thank you for the virtual accommodations. As she said, I'm Dr. Samuel Dent, representing the Engineer Research and Development Center, part of the U.S. Army Corps of Engineers. And I've also got a couple of my team members listed on this title slide. Great group of people, could not have done this project without them, and happy to represent them. One of the cases we were looking at with this wildfire is what we dubbed a worst case fire scenario, where you don't have a lot of information. You have a forested area, and a fire is going to start in some random location inside that area. Maybe something like a lightning strike happens. And so then the fire will start there and then spread to anything that's connected to it. And we don't have a way to fight the fire while it's happening, but we do have the ability to place these fuel breaks ahead of time, which are just treated areas of land that help prevent that spread. So the traditional methods for where to place those fuel breaks are often very reliant on the people who are working on that area. And so our team came in trying to apply some optimization, give a slightly more formal process for that. And in particular, we were looking at turning the forested area into like a tree network. So if you'll go to the next slide, please. So in our research, we were inspired by D-Wave's publicly available example shown here, which had a very similar goal. So kind of the idea of the example is you take a very complicated graph, like something shown on the left in red, and you want to do classify the nodes in such a way that it separates the network. So you divide the nodes into either this major group on the left and the turquoise major group on the right in the darker blue, or a separator node in the middle in orange. And so there are no direct connections between the turquoise group and the dark blue group. They have to go through that separator group. So that's kind of exactly what we're looking for with our fire case, placing these fuel breaks kind of as our separators. If a fire breaks out in the turquoise group, it won't spread over to the darker blue group. And the underlying optimization is based on the idea of equal graph partitioning, where both of those major groups on the left and right have the same size. And this also kind of makes sense for our fire scenario. You can kind of think of an extreme example where if instead there's 25% of the nodes in that turquoisey color and 75% in the dark blue color, well, if the fire has a chance to start in any one of those nodes, then it's more likely to start in that bigger group and then consume all of it. So it makes sense to kind of keep the groups more equal. But one of the things that we explored was, well, what if we don't enforce it that they have to be exactly the same size? What if we let that group size vary a little bit, kind of add a tolerance to that, and see how that affects the optimization? So if you'll go to the next slide, please. So we created our tree network and ran it through D-Wave's hybrid solver, and it gave us several solutions based on that group size tolerance. And here we have two kind of representative examples from those solutions. So D-Wave's solver has suggested to us these orange nodes for where to place these separators, the fuel breaks, which would then separate the networks into the light blue and dark blue sections. So on the left, we have one where we had a stricter tolerance for the group size difference. They needed to be closer to being equal size. And D-Wave came up with 11 separator solution. Whereas on the right, we let it have more freedom. The group sizes didn't have to be as close together. And you can see the darker blue section is bigger than the lighter blue section. And that one only had 6 separators. So there is kind of a trade-off going on here. You can think of when we're doing these separators, these fuel breaks, that involves messing with the environment and has upkeep costs with it. So we want to minimize the number of separators, but at the same time balance protecting the forest from the fire spreading and consuming too much. So we have that trade-off seen here with these 2 representative examples. And then if you'll go to the next slide, thank you. So putting it in terms of more concrete terms, if we think about the land area associated with this, our network covered about 28,000 acres, and we compared our 2 solutions from the previous slide to a more traditional approach called the ridgeline method, which is the bottom row of that table there. You can see that its separation into 2 major groups. The larger of those groups had about 19,000 acres, which is roughly 66% of the total acreage, and used 190 acres as fuel breaks. So our 2 D-Wave solutions offer kind of alternatives to this, where if you're willing to spend a little bit more area for the fuel breaks with the 11 separator solution on the first row, then you get much better equal separation or equal distribution for the groups. So going down to about 16,000 acres, which is much closer to that 50% of the total. Or if you say, I'm fine with there being some inequality in the group sizes, but I want to use less fuel breaks, then the second row, the 6 separator solution, offers about the same level of equality in the group distribution, but uses only 114 acres, which is about 60% of what the traditional ridgeline method did. So that's a very brief overview of what we're able to do with D-Wave.
Thank you so much for sharing that, and I'm fascinated, and I'm sure the audience is as well, for learning more. And so for those of you who are interested in learning more, Sam has agreed to do a webinar for D-Wave. It will be on April 29th, and you can go to the D-Wave website to get information about that event and also register. Now I want to turn to the whole panel. And this might be a simple question, but given kind of your backgrounds in using traditional solutions and classical solutions for public sector problems, I want to start off with the question, why quantum? What was it in your backgrounds that said, we need to find something else, let's go to quantum? And Dale, I'll start with you.
Well, thank you, Allison, first, for allowing me to be part of another panel today. It's a great question, and we get asked that often. It's one of the questions that even our customer base wants to understand. Why are you investing in this type of capability development and experimentation? And it really, for us, it centers around who we are as a company. Our DNA is really about being innovative for our customers and bringing unique solutions that are going to drive better opportunities and better results for the customers that we support. So that was priority number 1 for us, was really, really aligning with who we are as a company. But number 2, the thing about quantum is it is really a great fit for the high dimensional problem sets that we work with and our customers care about. And so we're not out to in any way replace classical compute constructs and algorithms that are leveraging those types of capabilities. But we do believe that quantum has the potential to augment classical in a way that is unique and can actually provide better results than what we see generally in certain problem sets. What we are doing is not hypothetical. These are based on real operational needs from our customers. And we are seeing value on a day-to-day basis and improvements in some of the results that we're utilizing for those customers. So it's really about the impact that we want to have on our customers, and generally that's going to be a U.S. government solution. And we're just excited about the potential. And again, it will be a hybrid approach for us on how we evolve the different applications that we leverage with quantum.
Fantastic. Aleksander, what about you? Why quantum?
So I would agree with everything you have just said. We have done it for the exact same reasons. Yes, as a public transportation company, we do a lot of logistics, and specifically D-Wave. That's exactly what quantum annealers are made for. That's what they're good for. That's what they're optimized for. So actually trying out quantum computing in practice was something which just felt natural. And especially since we are innovative and we are always looking for new solutions, new things to try out, quantum didn't hurt much. And also this was around at the same time when AI started blowing up because of the release of ChatGPT. And many people, including me and many others, have expected a same kind of blow up to happen in quantum computing in the future. So we wanted to be ready for that when that time actually comes. And just starting with quantum for us wasn't that difficult because we already had some logistic experience. We already had experience doing optimization. And D-Wave already has lots of great resources on how to get started and everything like that. So it was just taking the first step, trying, testing it out, seeing how it works, seeing how well it performs. And yeah, it felt completely natural for us.
Fantastic. Sam, what about you? Why quantum?
Pretty similar experience with us. We originally didn't seek out quantum intentionally, but we were working on several networking problems that we were having a difficult time trying to use classical solvers. And then we came across D-Wave's quantum annealing solvers. And we're able to kind of get the basic understanding of what was going on and start working with it. And it was way, way, way faster and able to get us results for those problems. So ever since then, we've been looking for opportunities to use that new tool in our tool belt.
I like hearing way faster and better results. We'll keep that up. Aleksander, yesterday you talked about the ticket allocation that you guys built for Norway. And I know the US Department of Transportation released a report about types of everything from EV charging stations and transport network optimization and emergency management disruption. But the different regions are nuanced. Transportation isn't the same globally. So I'd love to turn to you a little bit and kind of understand, have you looked at the US Department of Transportation's work? What are the nuances based upon different regions, since we have a global audience here?
So that's a good question. I did look at the report, and I was fascinated and intrigued by everything they had said and written about. And honestly, for us, I think there's a lot of things we can learn from it, a lot of things we can take with us further, and maybe also many new things and ideas we can try and implement. And the things they mostly discuss about, we haven't really done. We have actually been thinking about, like, finding ways to set up charging stations for electric vehicles, specifically for our buses. Most of our buses are fully electric. So that's something we can look into in the future, and we were thinking about that. Now, the only difference here would be that once you have found an optimal or near optimal solution for where you put these chargers, then you just put them there and you're done with the optimization. What we are mostly interested in and where we think actually the computational advantage you get with D-Wave, where that actually shines, that is when you have a problem which you have to rerun repeatedly. Like, for example, in our ticket inspection algorithm, like where changes may force you to need to rerun to get a new route inspection, for example. So, and this is also where I think that the speed which D-Wave solvers offer is most beneficial when you actually have to rerun a problem multiple times. If you just have to do it once to find the optimal solution and then place the charging stations there, then, I mean, that's also good, but maybe you can afford waiting the extra hour or even days if you're just going to do the computation once.
Thank you. Speed is actually a very kind of key factor, not just in the solution set, but also speed to procurement. So Dale, I'd love to turn to you. There is a new kind of procurement platform that was created for the Department of Defense, and given Davidson's kind of mission focused in helping in national security, the Chief Development AI Officer at DoD created this Tradewinds platform. And D-Wave is the first quantum company on it. I know Davidson as well. So I'd love if you could talk kind of how and why Tradewinds for the audience here.
Yeah, so the biggest thing for companies like us is accessibility to customers. And so what Tradewinds offers is a very rapid procurement opportunity for companies that have capability that is vetted through Tradewinds and posted, and fundamentally gets approved by the CDAO and others that are part of that process. And what that means to us is, and we've got a concept out there, as you mentioned, it's called Apollo Vision. It's a AI-enabled ISR capability that we're hoping, to bring to other customer sets. And this gives them one visibility into the solution. They understand what it is. They understand the impact on the warfighter. They understand the potential, value proposition to those customers. And if they like it, they can quickly get access to it and connect with us to bring that capability to bear versus going through what generally is a very robust and sometimes stodgy procurement process that the U.S. government runs. So this enables us to avoid that process in a way that's very consistent with getting the right capabilities in the right hands at the right time.
And especially as the speed of innovation that happens with emerging technologies like quantum, like AI, that speed to procurement is necessary.
Absolutely.
Sam, obviously as part of the DoD apparatus as well, your center works on solving some of the most challenging problems. You do everything from military engineering to geospatial, water resources. You mentioned the wildfire management. How does quantum currently fit into your organization's mission?
Right. So kind of on the high level, the Department of Defense has listed quantum science as a critical technology area. So kind of even from the high side, we're interested in exploring the possibilities that we can tackle with quantum. More specifically at ERDIC, we tend to focus kind of on the developing algorithms portion of quantum science rather than like the hardware development. Looking at problems that are important to the DoD and Corps of Engineers. So a lot of the problems that we look at are field problems, and by field I mean like in a physics sense of you have all these points in space and time that have some kind of data associated with it. Like you can think of water flow being represented by vectors or using finite elements to represent parts of the atmosphere. And so this data is coming to us with this gigantic scale, which we would try to usually simplify using like linearization or finite element methods. Or we get water resourcing and construction logistics and other types of problems where we're dealing with a larger scale and complexity than maybe most other organizations have to deal with. And so that's where we're hoping to kind of leverage the power and speed of quantum to overcome that scale and complexity. And a lot of what we're doing in research is trying to figure out how to actually translate the problems that we're looking at to work with quantum computing or to fundamentally solve it in a different way to work with the quantum computing.
Fantastic. We can't wait to partner with you on those. So we heard from our professional services team earlier today. We talked a little bit about yesterday, and the interesting thing for those in the audience is how people engage with D-Wave, and D-Wave's technology is a bit different. So Aleksander and Sam, you guys both took a do-it-yourself approach, and you kind of accessed our systems. Aleksander, you kind of did it all yourself. Sam, you worked a little bit with our TAs and did it most yourself. Why did you pick that method? So Aleksander, I'll turn it to you.
That's a very good question. Why we picked that method is because we just decided we have to start. And what's the best way to start? Just to do it. And that when we started, we didn't have much experience with using quantum computing, specifically not D-Wave. And just how to get going, how to get started, is being able, not just being able, but actually daring to take the first step. And we did that. We didn't have any experience. And in the end, it turned out very, very good for us. We got a lot of attention, many people reaching out to us, asking how we managed to do it, how we dared to take the first step. So I think, yeah, that's at least how we moved along and why we chose the approach we did. But I also have to say that it wasn't super easy. I reached out to D-Wave, I got very good help, a lot of support. They gave me ideas, feedback, everything. So I have to give a lot of thanks to D-Wave as well. They've been very helpful in this, and yeah.
Wonderful. Sam, why did you guys take a do-it-yourself approach?
Pretty similar situation for us. Our team tends to work on projects where we need to, conquer something very quickly. So we just kind of found D-Wave and started using with what we knew, which we also did not have that much experience at the start. So we were, looking at the publicly available examples and just trying to get a basic understanding of how to structure our Python code to interact with D-Wave solvers. As our team leader liked to say, we knew just enough to be dangerous. So after the initial success, we were able to get some more formal training with D-Wave and also purchase more direct access to some of the D-Wave staff who have been fantastic. We've worked on a project where there were some minor changes and then there would be a major change where we're looking at something completely different, and they were with us every step of the way and helping to connect with the right people who might have a better expertise or try this other solver or things like that. So it's we're grateful.
Oh, fantastic. Well, Dale, Davidson kind of took the other approach. You kind of partnered with our professional services team. So why did you pick that approach, and what was the learnings from that?
Yeah, so I think for us it was really about how can we innovate as quickly as possible, and really as a small business bring as much power to the problem set with the resources that we have available to do it. And so by partnering with D-Wave on this, we were able to get a lot done very quickly, and that professional services team is exceptional. Anybody looking to get involved with quantum and doesn't know where to start, I will tell you that is the best way to do it. If you're looking for speed and impact. And it really showed through for us. We were able to quickly iterate and experiment on 3 fundamental technology areas, weapon to target pairing, radar resource scheduling, and some other optimization problem sets, all within a year's time frame with minimal resources from our perspective utilized. So again, it was really for us about how quickly can we have the type of impact that we're looking for and the value that we're going to need for our customers.
Well, and I know from talking to our professional services team, they loved working with your team because you guys understood the mission set and the objectives and the problems. And so I'm happy that even through the do-it-yourself method, our team could actually step in and help and give suggestions on which solvers to use, or if you got stuck, how to help. We just heard a presentation from Verge about autonomy in farming. And I know autonomy is actually an area that impacts a variety of different industries. So Aleksander, I'm going to turn to you. I know Ruter also is exploring the use of autonomous vehicles. Do you envision quantum kind of coming into play in that?
Yes, we do actually, and it is something we have been thinking about for a long time. So how to do it is maybe the more difficult question, but yesterday I spoke about how we used quantum computing for our on-demand vehicle allocation project. I think that using D-Wave for allocating where to put autonomous vehicle most effectively is a good approach, and it's also very similar to what we have already done. This is actually one of the good things with optimization in general, is that you may have problems which seem fundamentally different, but mathematically they are the same. And also if you do it in this way, like especially right now, autonomous vehicles are known to somehow get some problems, like for example, someday the sensor might not working, or maybe it will need a recharge, and then actually having backup ready for when this happens and having it at the perfect time, perfect place. That's something which we think that D-Wave and quantum annealers can be very helpful for, actually finding these best places to put them. And it's also something which needs to be adjusted dynamically. It can change from day to day, from hour to hour, month to month. Norway also has some, especially Oslo, has some very nice weather during the summer, and you could say also very cold winters. Like where to put these backup vehicles may change from summertime to wintertime. And yeah, that's one way where we think we could combine the two.
Fantastic. Well, not that there are cold winters in either Alabama or Mississippi, but I know autonomy does relate to the Defense Industrial Base in areas of vehicles, robotics, aircraft. So turning to Dale first, you, and then to Sam, kind of where do you see kind of quantum fitting into the autonomy for the mission sets that you're looking at? So Dale?
Yeah, so I think you're seeing a significant increase in the use of autonomous platforms across the U.S. government, and that's air, land, and sea. And so there's a lot of optimization problem sets that are a great fit for how those platforms operate. You think about routing, rerouting, tasking, threat assessments, terrain and environment assessments as they are doing what they do. So we believe that quantum, as a platform, enabling those autonomous systems to get better, and particularly in very complex environments, that's kind of the key for us. Precision and speed and effectiveness in very complex environments is going to be critical. So yes, we absolutely see quantum playing a role there in addition to all the other capabilities that are a part of those systems.
Perfect. Sam, what about you?
Pretty much echoing what's been said so far. From my limited experience, I can see from kind of a logistics or allocation point of view that having all those autonomous vehicles interacting with each other and the environment could definitely use a boost from quantum, especially at those super massive scales.
Well, thanks. I'm going to finish off the panel with lightning round questions. And this is always one I'm always love to ask and interested in the answer. So Sam, I will start with you. So what is still the biggest misconception you hear about quantum computing, and what most excites you about the future of quantum? So Sam?
For me personally, the biggest misconception is the difference between the gate-based and the quantum annealing styles. I have to regularly explain that difference, sometimes to the same people. But explaining that they're different, they have strengths that play to different things. And the thing I'm most excited for in quantum is the accessibility. Especially with something like D-Wave's cloud-based approach, where you don't have to have the supercomputer right next to you. You can still access it with normal hardware, and it's available right now.
Fantastic. Aleksander?
Yes, so I would agree with everything that was just said. For me, maybe the biggest misconception would be that quantum is always better, or it has the potential to be always better. We know that's not entirely correct. Quantum excels in some areas, like it seems to do optimization very well. So knowing where and when to use quantum is the key. And yeah, I'm also mostly excited for how easily it is accessible to use quantum computers nowadays. Again, D-Wave's cloud system, just in general, that it's getting easy to use and start using. There's good documentation online. You get good help and support from D-Wave if you ask for it. So just starting, it's much easier today than it was just a few years ago.
Right. Dale, close us out.
Yeah, so I think the biggest misconception from my standpoint, and particularly from our customers' perspective, is that quantum does exist today and it is operational. It is not just an experimental capability. It can be leveraged to solve real-world problems today. And this is not a hypothetical situation. There are real operational needs where quantum can play a role in having an impact. And for us, what excites me most about quantum is that we are going to have a D-Wave Advantage 2 system in our facility in about a month, operational in about 2 months. And that's real, that's happening. Our customers are going to be able to put their hands on it, see it, and utilize it for the first time in the state of Alabama. And we're just excited about that partnership and where it's going. So
we're excited too.
Forward
Thank you all so much. Appreciate it. And thanks, everybody.